Morning, everybody. It is Captain Chris here again from the education team at Save the Bay, coming at you with another edition of our Facebook live stream called Breakfast by the Bay that we're doing every weekday morning, Monday through Friday at 10 a.m., trying to help you stay up on all of our Narragansett Bay and world ocean issues to keep it a part of your classroom while that's at home instead of at school. Really excited for you to be joining us today. We've got a really important topic to talk about that has a lot of information and then ends with some really cool kind of experiments and things you can do at the very end. So stick with me, I promise it'll be worth it. We're going to be talking about something called ocean acidification. So some of these topics can be a little complicated. If you have any questions or comments, it's all right. Please just type them up, put them in our comments section, and Ms. Letty, who's behind the camera, will be super happy to shout them at me, and hopefully she's only going to give me the easy ones, so I'll know the answers and I'll look really smart. She's shaking her head no, so she might throw some hard balls my way, but don't do it, Letty. So please let us know if you have any questions. Also, we'd love to know kind of where you're tuning in from and what your home school is when you are back in school. You can add those in there as well. So we're going to be talking about ocean acidification. It's a negative thing that's happening in Narragansett Bay and around the world in our oceans. And I want to talk about it, but first we need to talk not just about what it is, but why it's happening. And the why it's happening is because of something called climate change. So in order to understand ocean acidification, we're going to talk about climate change first. So we're going to go over to the other board and I'm going to explain a little bit about that. And as I transition, I just want to again reintroduce myself and in case some people are just tuning in. My name's Chris. I'm here as a part of the education team from Save the Bay, coming to you with our Breakfast by the Bay series, which we're doing each morning, talking about topics related to Narragansett Bay and our oceans. Today we're talking about ocean acidification and how it's caused by climate change. So what I want to start with is by talking about our planet and this big invisible layer of air that wraps it all up called our atmosphere. So in case you couldn't tell, this is our planet Earth. This is home for all of us, everybody tuning in. And I'm going to draw this circle wrapping our planet up. This is going to be our atmosphere. It's this invisible layer of gas that's tens of thousands of feet tall. And if you are to leave the Earth on a rocket ship and go out that atmosphere, once you leave the atmosphere, that's when you're in space. Now, I don't want any of you to do that. It's really comfortable here on Earth. Please don't go out into space. It's pretty gnarly out there. So stay inside the atmosphere. But the atmosphere is really important that we have because it traps a lot of really important things inside. One of those is a gas called oxygen. Oxygen makes up about 20% of our atmosphere, and it's what we breathe. So if that atmosphere wasn't there, all the oxygen would get lost out into space, and we wouldn't be able to live here. So it's very important that it traps that oxygen. All right. There's also some other gases that get trapped that make up the atmosphere called nitrogen, N2, and also carbon dioxide. So those are the three really big gases that make up our atmosphere that our atmosphere traps. Now there's also something really important that our atmosphere traps, and that's heat. And that heat, as you may know, is coming from the sun. So I'm going to draw a big old sun here. Now this is a lot closer to Earth than our actual sun is, but I only have so much board space to work with. So you have to pretend it's a lot further away. So when heat leaves the sun, it travels towards Earth, and a couple things happen to it. So this is my wave of heat coming at the sun. Now some of that heat, when it hits the atmosphere, bounces back. The atmosphere won't let it in. And that's okay, because if all the heat from the sun got into the Earth, it'd be way too hot for any of us to live here. So some of it hits the atmosphere and bounces back. It hits that blanket and bounces away. Some of it travels towards Earth, comes through the atmosphere, hits the Earth, and is absorbed. Darker surfaces absorb a lot of this heat. So something like the ocean absorbs a lot of the sun's heat. But something like ice that's white reflects heat. So that's why during the summer, if you put a couple things out into the sun, the darker one's going to get hotter because it absorbs a lot. So some of the sunlight comes into the atmosphere, hits a surface like ice, and bounces away and actually escapes back out the atmosphere. Now remember, that's important because if all the heat got trapped, it'd be too much. And then last, some of that heat leaves the sun, comes inside the atmosphere, and is reflected back, but when it gets back to the atmosphere, it's trapped again. And that bounces back and forth. So this kind of even amount of heat leaving and heat staying makes our planet habitable. It's a very good thing that this happens. Because if there were too much or too little, we wouldn't be able to live here. If we didn't have an atmosphere, Earth would be a lot like the moon, which has no oxygen to breathe because it all escaped away. And it is really, really hot during the daytime because there's nothing blocking all of the heat. And it's really, really cold during the nighttime because there's nothing trapping any heat in. So it's important that we have an atmosphere made up of carbon dioxide and nitrogen and oxygen. And the gas that does a lot of trapping of this heat is carbon dioxide. And it's important that it's there. But unfortunately right now, we have a lot of extra carbon dioxide, this CO2. Because for over 100 years, humans have been doing something which is called burning fossil fuels. So if Ms. Letty wants to zoom in a little bit, I have a picture of something called the carbon cycle. Now this image is able to be downloaded in the description of our video. We've got a link to it over in the side. And so what humans have been doing for over 100 years is removing something called fossil fuels, which is this stuff right down here. Oil, coal, and natural gas. We've been extracting them from the ground and burning them to make energy, which has been really helpful for us. We use those fossil fuels to make energy to create electricity, to heat our homes and light our homes, to turn oil into fuel or gas to power our cars, and also factories will use this to make things, to create energy to make things. But when you burn oil, coal, and natural gas, you release a lot of this CO2 out into the atmosphere. So if we zoom back out, if a lot of that CO2 is coming out of a smokestack, it is added to this blanket of air, this atmosphere all around us. And the more CO2 that's in our atmosphere, the better job it does at trapping heat. Now remember, we're pretty comfortable as it is, so any more heat might be a problem. So we don't want all this there. So that is how these gases, called greenhouse gases, are causing climate change. Now there could be a whole day's lesson about this, but it's not what we're here to talk about today. I want to learn how increasing the CO2 in the atmosphere causes what's called ocean acidification. So we're going to transition over to our table where we've got some cool experiments set up. And as we move over, I just want to take an opportunity to reintroduce myself. So again, I'm Captain Chris, part of the education team at Save the Bay, coming to you with another live edition of our Breakfast by the Bay Facebook Live streaming series that we're doing every Monday through Friday at 10 a.m., talking about a lot of current topics affecting Narragansett Bay and our world and a lot of the plants and animals that call these ocean and estuary habitats home. Today we're talking about ocean acidification and how it's caused by climate change. So we just introduced the topic of climate change caused by increased carbon dioxide in the atmosphere. But we want to know how that's affecting our ocean. So not only is there a lot of CO2 going into the atmosphere, the gas around us, but a lot of it ends up going down into the ocean and dissolving in with water. And that's a problem, because if you mix CO2, carbon dioxide, and water, you get something called carbonic acid. And that's bad if there's a lot of acid in the ocean. To understand why that's bad, we need to look at what's called the pH scale. So I'm going to introduce the idea of pH to you and the pH scale. So if Ms. Letty wants to zoom in on our pH scale here, I've got a diagram. And this is something that's also available in as a downloadable link, an image in the description of this video. This is a pH scale showing the pH of common household items you might find, everyday items around inside your house. So to measure the pH of something is to tell whether it is an acid or a base. And this pH scale goes from a 0 to 14. You see it all right there, Ms. Letty?
You could tilt it back up.
All right.
Perfect.
So it goes from a 0 to a 14, all right, which means directly in the middle, a 7 halfway is what's called neutral. And the only substance on planet Earth that is a true neutral, 7, is water. If a substance measures below a 7, a lower number on the pH scale, then it's considered an acid. Common acids you might find in the home are things like lemon juice, vinegar, or tomatoes. Or even inside your stomach, you have a very strong acid, like a hydrochloric acid, that is even stronger than lemon juice. If you are above a 7 on the pH scale, you're what's called a base or alkaline solution. Common items you might find around in the house that measure as a base are things like baking soda or a lot of cleaning products. The scale is in this beautiful rainbow color because those are the colors that these solutions will turn when they're in the presence of an indicator solution that we use to figure out the pH. So again, that pH scale is available as a downloadable link in the description of the video. So later on, what we can do is Ms. Letty and I have made a video that's going to be posted later on today where you can determine the pH of household items making your own indicator solution. Here at Save the Bay, though, we have a super scientific indicator solution called bromothymol blue. This is a very precise indicator solution that helps tell us anywhere on that scale of 0 to 14 what pH a solution is. All right? So we're going to use this today and show you what happens when an indicator solution is in the presence of an acid or a base. So I have here just a giant cup of water that I got from my Brita filter. So we filter the water out so I know it's just water. Now if you remember, I said water is a very important solution on our pH scale. So think about if you can remember where that should be coming in our pH scale from 0 to 14. I'm going to add our indicator solution and see what happens. So squirting a whole bunch of this in. And if we see here, this turned that green color. So on our pH scale, that green tells us exactly what it should, that our water is a 7 or neutral, right? So this is why the colors on the pH scale are the way they are, because that's how this bromothymol blue will turn in the presence of these solutions. So green means a neutral solution. So I'm going to add some of this green water. Remember, this is just plain water and our bromothymol blue indicator solution. I'm going to put some in some other cups and see if we can introduce an acid and a base and find out what happens. So in my cup here, I have a little bit of white vinegar, which a lot of us have laying around the house. So this is one of our household items that we can test. So I'm going to pour our vinegar into our indicator solution. And if the pH changes, so should the color of our solution. So let's see what happens. We'll get nice and close. Mm-hmm. All right. And I'm going to pour this in. Oh, wow. Look at that. So again, if we are looking at our pH scale compared to the color, it turned that orange color, which is exactly what we were expecting, right? That vinegar turned that orange color, which means it is a 3 on our pH scale, which means it's lower than a 7, so that means it is a acid. Awesome. So now we've created an acid and seen what happens when we put it in the presence of an indicator solution. I want to show you what happens when we add a base. So I have a little container here. I'm going to add some baking soda. Now you might remember where I said baking soda is on the scale. We'll see what happens. So I'm going to sprinkle some baking soda in. I'm going to put a bunch because I want a really good color change, and we'll spin it around. Oh yeah, look at that. So we have got this really beautiful blue color, right? So this might even be a little bluer than what we see on our scale. So on the pH scale, it says that baking soda is around a 9. We might have even got a little more of a base than that. So this is coming in above a 7, which means our pH is a base or alkaline, right? Awesome. So that's what it looks like when the pH of a solution changes in the presence of an indicator solution. But how does this all relate to global climate change and ocean acidification? You might say, that's a really good question, Chris. I'll show you. Any questions or comments to address right now, Ms. Letty?
People are really impressed by the color change. It's really cool.
I'm really impressed by the color change. I've done this dozens of times, and I still love watching that happen right before your eyes. It's great. Mm-hmm. So I want to show you what's going on in our bay and in our ocean around the world. So Ms. Letty was nice enough this morning to get us a sample of bay water from down by our docks here at the Bay Center in Providence. So I'm going to take some of this bay water, and I'm going to put it into a cup, and I'm going to add some of our bromothymol blue indicator solution. Now remember, the solution changes colors depending upon whether or not the substance is an acid or a base. So Ms. Letty, if you want to get nice and close again, we'll see what happens. This is just our bay water. So this is what you'd be swimming in if you're swimming around in Narragansett Bay. So I'm going to put a bunch of that in. All right. You might be able to see there that this turn, can we make it out there, Ms. Letty?
Yep.
All right. So that is not a green color like that neutral, like pure water, right? It's higher than that green. It's a blue, so that means, is it an acid or a base? Yeah, it is a base. It's basic. And that's because the bay water is not just water. Our bay water has a lot of other things mixed into it, and one of those things in particular makes this a base. And that solution that's mixed in, that thing that's mixed in, is called calcium. Now calcium, you might have heard of it. It's in milk. It's why people tell you to drink milk to get big, strong bones, right? So there's calcium in bones. There's also a lot of calcium in shells, like this clam shell. We talked about the shells of clams and other mollusks weeks ago in our very first Breakfast by the Bay series. So these shells are left behind from animals like clams and scallops and mussels, and they make their hard protective shell out of calcium, just like you make your hard bones out of calcium, right? So what happens when they die, their shell is left behind, and a lot of times we walk around on the beach and it's not these beautiful whole shells, but these pieces. And the shells get broken into small parts from waves and banging against rocks and things like that. And as they get smaller and smaller, they break down into a fine powder that mixes into the bay and mixes into our ocean. All right? It's a lot like when I sprinkled baking soda into our water. It made it a base. So if you sprinkle a powder of calcium into the water, it makes it a base. So I knew this was going to happen. It's very important that our bay water is a base. It's because of all that calcium. Because when these clams are little tiny babies, they're plankton, which Ms. Letty is going to teach you all about next week. And they get a lot of calcium from their environment, from the water around them, to make that hard shell. So if the calcium's not there, they can't make a shell. It's really important that it's a base. So what I want to show you is what happens when we add our bay water to a little bit of carbon dioxide. So remember, I'm going to put a little of our bay water right in here. I'm going to shoot in a little bit of our bromothymol blue. Now, you already saw what color is it going to turn. Yeah, we're going to get that blue. Awesome. And now I'm going to put in a whole bunch of carbon dioxide, just like is happening in our atmosphere and in our ocean right now from our climate change. We're getting a lot of CO2. So I'm a human, just like you're a human. I breathe in oxygen just like you breathe in oxygen. And when we breathe out carbon dioxide. So I can breathe out and add carbon dioxide to our Narragansett Bay right now. I'm going to do that by blowing through my paper straw. Now you can pretend also that maybe I am a car and this is my muffler, or I'm a factory and this is my smokestack, and I'm putting carbon dioxide into the environment. So I'll do this down on the table, and I'll try and hold this white card behind so we can see what happens. Now remember, I mentioned before, something is made when you add carbon dioxide to water. And if the pH changes, the color of the water is going to change. So let's see what happens. This might take 1 or 2 breaths.
Ooh.
You might already start to see some changes happening right now. If you can remember what our pH scale looks like, see where that is going, right? I'm going to blow one more time here. And you guys tell me in the comments section what's happening to our bay water and the indicator solution. Yeah. So what do you think, guys? What happened there? Did we change the pH of the water by putting carbon dioxide into it? Yeah, absolutely. And we know that because the color changed. So it started out up here around an 8 at that blue color, blue-green. And we just dropped it down, maybe even beyond a 7, towards a 6, that really light green color. So is our bay a base or an acid now? Yeah, I'm sure you guys are shouting it at me. It is an acid, so we made our base slightly acidic. And that's because, like I said, when you add carbon dioxide to water, it makes carbonic acid. So that acid neutralizes all the calcium, and it's not in the water anymore for animals like these clams to make their shells out of. So that becomes a problem because they can't grow big and strong. They won't be able to make a hard shell for protection. It's very weak and limp and flimsy. And even things like little baby fish can't make their bones. That's a big problem, and it's something that's happening all around the world because all of that carbon dioxide is getting added to the water. Now, if you want to do an experiment to see what the pH of some household solutions look like, later on today, a video is going to be posted showing how you can use a simple red cabbage to make your own pH indicator solution and test a lot of household items on your own. It's not quite as fine-tuned as this indicator solution, our bromothymol blue, but you'll be able to see if things are acids or bases. Another really fun experiment that you can do is over here, something that Letty and I have set up just a little while ago, well, days to weeks ago, really. And that is, you can take a shell, if you have any shells laying around the house. If you're like Captain Chris, I hoard shells. I just gather them at the beach all the time, so my house is loaded with them. So you can take a shell, remember it's made out of calcium, which is a base, and you can add it to a whole bunch of vinegar, a cup of vinegar, which is an acid. So you can take some shells, put them in a cup, pour in some vinegar, and cap it. Give it a swirl so it's all mixed together, and just set it aside. Leave it for a couple days, maybe 3 or 4 days would be enough. And you can make some observations as you go. You might see some bubbles and things like that. Because what's happening is the acid of the vinegar is starting to neutralize the base, the calcium of the shell. And after a couple days, if you take that shell out, I'll show you what happens. Ms. Letty's going to get really close here. So as that vinegar neutralizes the calcium, it makes our shells weak. So if I try and bend, look at that, that shell breaks so easily. So this shell would not be great for protection anymore. This would not be something that would protect that scallop. And that's after only just a couple days. And if you leave it for a couple weeks, what might happen, this mussel shell, you can see, is super limp and flimsy. So all of that calcium has been eaten away because it's been introduced to an acid. Now, vinegar is a much stronger acid than the ocean is becoming right now. So this isn't necessarily exactly what's happening in the ocean, but it's kind of an exaggerated and sped up version of what might happen if the ocean got any more acidic than what we're seeing today. Any questions or comments, Ms. Letty?
We do have a friend that wants to know, what can we do to make sure our bay doesn't become more acidic?
That's great. So a couple things you can do. The best thing that you can do is try and reduce the amount of carbon dioxide that you might be adding to the atmosphere. And there's a couple easy ways you can do that at home by simply making sure you're using less electricity so that less fossil fuels are being burned in order to make that electricity for you. Another thing is a lot of states give you the opportunity to sign up for a couple extra dollars a month if you're able to make sure that your electricity is coming from a renewable resource like solar or wind. So those are a couple options at the home. If you are able to drive less and use your bike or walk places, it's another great way to make sure that you're using less fossil fuels, burning less fossil fuels. Also, a lot of those fossil fuels being taken from the ground are used to make plastics. So if you're able to use less plastics in your day-to-day life, you'll be helping out a lot. Also, if you're like Captain Chris, I've started to become a little guilty about all the shells that I take home, because if this shell is not in the bay anymore, then that means that calcium is not in the bay anymore. So anytime that I get a bunch of oysters or things like that, if I don't want the shells, instead of putting them in the garbage, I always walk them back to the beach in a day or two and put them back into the water to make sure that that calcium is around for another little baby oyster or clam to use to make its shell when it's growing up. Really great question.
Great.
Anything else?
Yeah, our friend Janine wants to know, is ocean acidification only impacting the shells? Or our shells?
Oh, really good question. No, so ocean acidification is impacting a lot of animals. So I mentioned a lot of these animals with shells, like our mollusks. Also, a lot of fish that use calcium to make their bones. So there are a lot of scientists doing some work studying how the reduction in calcium affects their ability to survive as babies. Also, coral reefs are made out of calcium as well. And in places all around the world, people are starting to see coral reefs even slowly start to dissolve and erode away. Places like the Great Barrier Reef are seeing increases in the amount of ocean acidification that's happening. The pH is getting lower and lower. So coral are another group of animals that are very heavily affected by ocean acidification. Now, great question, Janine. Thank you. Well, if that's all we've got for right now, I want to say thank you all for tuning in and watching our segment all about climate change and ocean acidification. Remember, at home, you can do two things if you want to today. If you have some shells around, put them in some vinegar, and remember to make some observations and check back in a couple days or weeks and see what starts to happen. And then also, be sure to tune in later on this afternoon. It's not live. We'll be posting a video, a pre-recorded video though, where I show you how to make a indicator solution, a pH indicator solution at home out of just some simple red cabbage, and use that to test different items around your house for their pH. So thank you so much for tuning in. We really appreciate you all watching every day. Make sure to tune back in tomorrow at 10 o'clock for another live edition of Breakfast by the Bay. And if you love what we're doing and want to support Save the Bay's mission to protect and improve the Bay, we always appreciate donations. If you're able to, you can follow that donate link in the description of our video. But thank you all again for tuning in, and we'll see you tomorrow.